Norway, and this one is Beyonder, and it's about yes, I would say high power, great life cycles in batteries, and the way to this one. And I think we have Jasmin with us. Jasmin,
Yes.
your
Thank you.
prominence was yours.
Thank you very much for the invitation and possibility to present Beyonder at this webinar. My name is Jasmin Arifagic. I work as a VP sales in Beyonder, and today I would like just to drag you through Beyonder offerings at product level, where our focus is high power and long cycle life battery technology. Just to give you an idea, we all know about the power and energy spectrum, where we have supercapacitor on the left-hand side offering quite excellent power properties. You have the energy density battery technology, which has evolved quite good, driven by EV market last years. Excellent technology, but very good on energy density, but cycle life and power properties not that good. So Beyonder was established in 2016 with an aim to electrify and help electrify the industry, industrial application, to reduce the carbon emissions. In that way, we saw quickly that we need diversity in the battery technology. So our focus was to bridge the gap between these two excellent technologies and develop battery cell technology that is combining these in a way and offer very good power property in addition to good energy density, and still maintain the cycle life. So here, just given with a few examples where the kind of technology would fit in, this is just a few of them, but typically in maritime industry, heavy duty and the power backup applications. So over the last 8 years, we've developed the technology, and our first commercial product now is released, produced at large scale, giga scale. We have chosen a business model where we outsource our technology and produce it at large scale production facilities until we are capable of building that infrastructure in Norway and Europe. So for now, we've secured commercial production, and this product is fully certified and tested and available for customer orders. What you can see clearly is that it is a battery cell, which has 120 watt-hours per kg, but the power properties from a single kilogram of this cell is 3.3 kilowatt, which is enormous power, and in addition to quite excellent cycle life. So for those that are more interested in the product itself, how the cycle lives are, what you can see in the left-hand side is the cycle life graph, where we have continuous cycling of our products. So fully charge and discharge within 12 minutes, 0 to 100%, only 2-minute rest time. And we can do it over more than 10,000 times, allowing the remaining capacity on cell to be 70%. If you reduce your C rates and apply and allow for even longer charge time and discharge than 12 minutes, you could actually increase the lifetime to up to 15 and 20,000 cycles. So it provides you flexibility to use this cell as a traditional 1-hour cell, or you could actually use it and be fully charged from 0 to 80% in 5 minutes. And what is also interesting to see is the thermal properties of the cell, where heat generation at constant cycling over several thousand cycles is very low. And if you want to compare this technology to something that is familiar out there, the closest performance-wise would be LTO technology, for those that are familiar with that. Given the fact that this is an LFP chemistry, so cost-wise, this would be a very attractive solution over an LTO. And the performance-wise, with the power capabilities and the cycle life, it has gained good traction within mobility market, where 12 and 48 volt batteries are coming up as good potential applications for this. So taking it from cell, we are also working with mobility modules and tailor-made for heavy-duty applications, buses, trams, rails, and so on. But we're also working on 12 and 48 volt modules with our partners, and stationary storage. So this is really to help speed up the product into the markets. I think I maybe spent my 4 minutes, but this is really what I wanted to share with you, the purpose. And if in case you're interested to hear more about Beyonder or these products in general and how we actually do this, please reach out and we'll gladly set up a call or whatever is needed to yeah. I think you are muted.
Here we go. I muted myself. I just one quick question. What is your call to action here to the audience?
Well, I think what it is, it's actually that we are going commercial. So we are looking for customers, partners where we can develop further and offer this product to our customers and help them electrify their application.
May I ask, at what technical readiness level are you at the moment?
Sorry, I didn't get the...
At what technical readiness level are you at the moment?
Oh, we've produced C samples, so we are fully commercial for the cell itself, and the module development for the mobility is already B and moving now into C phase. So the cell is ready for order, and we secured 5 GWh of production capacity. So we are more than ready to deliver the cells and the modules. Some of these modules that you've seen have, of course, different stages, but one of them is already delivered to a few customers and are being tested and evaluated.
Is there in the pack the BMS is already implemented?
For the mobility module, it is not included BMS, so it's intended to be placed in a pack solution with where the BMS will be added. For the stationary storage, we are of course working with the BMS as well.
Okay, one last question, please. You said you're aiming for similar characteristics like an LTO, but for the price of an LFP. That would be very interested, as we have a client at the moment who has the problem, who is bound to an LTO technology.
Kevin, stop, hold on. Yeah, Kevin, can you directly connect to Jasmin? I've put his LinkedIn link in the chat. Please connect to him directly. Go on a call with him, have a chat with him. We have one question, a couple of fuel cell in Norway. Do you produce in your own factories?
Well, no, we have innovation line in Norway where we have developed up to A sample. And then, of course, moving from A sample to C sample, you need large facilities, you need large production lines, which is quite costly to build up. So the technology is developed here. It's produced, machine-produced cells, but then we moved and outsourced the production to Asia until we get traction commercial-wise and are able to build commercial lines in Europe or Norway.
Okay. We have one other question. Has a cell passed the propagation and internal short circuit test from IEC 62669, whatever that is? Where were these tests done? What would be the price per kilowatt hour?
I think for all those details, of course, please connect with me. We'll answer all of them. Here are some certifications. So IEC 62619, yes, it has passed. TÜV has done the tests, so it is more or less ready commercially to be done. So all tests that are part of mentioned certifications in this slide have been done, and we have available reports. For the commercial aspect of the cell, we can of course take those directly. Please get back to me, and we will discuss those things.
But just it saves the chat, so you have some question in there from Conchev. We have another question from Hans. Hans, you were quite early. I know that. Please ask directly Jasmin at the chat because of the time, because it's about if he offers the link girl stuff like that. Yeah, just please connect directly to Hans. Let's